All right, so we're here with Jens Eliasson from ThingWave.
Yes.
So yeah, tell us a little bit about why you're here at IoT World.
I'm a researcher at the Lulu University of Technology.
Okay.
And last year we entered the IPSO Challenge competition with our device, which is called the Smart Rock Bolt.
A smart rock bolt.
A smart rock bolt,
okay.
Yes. So rock bolts are used primarily in mining,
okay.
but also in construction of tunnels, for example, to reinforce them. But in mining you have a lot of activities, right? You have seismicity, you have blasting, a lot of mining activities,
right.
which can actually cause these devices to become damaged.
Okay.
And if that happens, you can actually have ceiling collapses.
Got it.
Which could actually hurt or even kill miners. It can damage equipment, it can cause stop in production.
Okay.
And there's a big problem because since these are inside the tunnel wall, you cannot see if they're okay or not.
Right.
So what we did is that we embedded different type of sensors in this rock bolt, and this should be around 3 meters long.
Okay.
So we added sensors, we added signal processing, wireless communication, data storage, all that.
Okay.
So now we are monitoring for seismicity, we are checking the load of the rock bolt, and we are checking if it's broken or not.
Yes.
And we are sending wireless alarms to the mining company so they know if the tunnels are secure or not.
Interesting. And so what led to this creation? I mean, what led to this?
LTU, which is my university, we were funded some 4 years ago to support the Swedish mining industry.
Okay.
So we have a lot of mines close by. And one of the Swedish mining companies, I think around 10 years ago, said, you know, it would be great if we could know if the rock bolts are okay.
Yeah.
And 10 years ago there wasn't really any suitable technology to deliver that.
Right.
But today there is, and last year we entered the IPSO Challenge competition, and we got the first prize.
Congratulations. Out of there were 15 finalists, is that right?
It was 10 semi-finalists that were invited to San Jose.
Yeah.
To the Designers of Thing exhibition, so we took first place, and from there we started ThingWave, which is then a spin-off from LTU. Today we are here to represent LTU and ThingWave. Yeah.
And so tell us, so what's ThingWave? What's the goal behind ThingWave?
Well, ThingWave, the goal there is to bring research results from LTU. We're also part of this. We're doing solutions for highly efficient, secure wireless communication. So we took all these results and we said, let's do a startup so we can actually go to the market, because there's a clear need and we see a huge interest from the mining industry.
Right. So that's your focus.
Which is really, really interesting.
So ever since creating this and winning, you've seen you're getting a lot of interest from mining companies asking specifically about this.
So we've now been offered to do a number of installations.
Oh wow!
So hopefully we're going to have these devices installed in several mines within the next 6 months.
That's fantastic.
Where we're going to start doing field testing. So every component or part has been tested either in the mine or in the lab. But this is the first time we're doing a complete system integration and testing in a mine.
Really? And so, that's fantastic. So, is there research around, so in terms of safety, right? We've seen a lot of mine collapses over the years.
Yeah.
What is there research, or is there something telling you that we can reduce the damage or reduce the number of those collapses happening because of this technology?
Yes, exactly.
Yeah.
So, like I said, we have 3 different sensors.
Right.
We have one sensor that will tell you if this bolt has actually been snapped in half. And that is the ultimate warning sign.
Right.
Then we also measure the load on the bolt. So before it breaks, we can know that it's at a certain level, maybe a dangerous level, and that means you might go in and reinforce to prevent it from breaking.
Got it.
And that really helps. And then we're also doing seismic monitoring, which means we can detect the amount of vibration energy that each rock bolt has seen individually. Not as a tunnel or a mine, but each individual rock bolt. Because if you have shock waves, for example, when you have an earthquake or a mine quake, you get shock waves traveling several kilometers per second through the rock. And when those hit open air, they reverse back. And that causes damage to the rock bolts because of this shock wave. So we really want to see what's the level of these shock waves, how many are they, and after the shock wave, what happened with the load. Because if it changed, that means something happened with the structure of the rock bolt. So we can see the frequency and the amplitude of these waves.
So there's 3 layers of protection, I mean,
Yes.
all the way through. Like, we need to get in there and fix this right away.
Right.
We have enough time to brace for potential.
We don't need to wait until the rock bolt says
Exactly.
unbroken. You can
Exactly.
actually, if you say I'm almost broken, we'll go and reinforce
Yes.
or take other actions.
Great.
We also added these high power LEDs. So if you're in the dark tunnel, these are really powerful. And if there are, for example, seismic activity at a certain level, we are showing. If we have a high level, we also have a green blinking every couple of minutes, just to say that everything is okay, the battery is fine. You know, so if you're a miner, you see it blinking green, you know you're safe.
Got it.
We also have a really high power white LED. It's like a flashlight. So in case of a fire or evacuation or any other reason, you can, for example, take a smartphone, just say lights on, and the whole tunnel will illuminate.
And so you can, interesting, like on an airplane.
Like on an airplane.
Wow.
You could even program these devices to say, do a light pattern to show the nearest exit. Should I go up or down? Because sometimes you want to go down to go up, right?
Yes.
So we could program these to kind of do a blinking pattern, like a runway, to say, this is the place to run.
It's incredible.
Yeah.
So, really, I mean, I'm sure there's more things you'll be able to do as you know, you put these into production and
Yes.
you know, I'm sure through experience. So that's fantastic.
What I think will happen is someone else will, when they see that we have this sensing infrastructure, they're going to be completely new applications with things I never thought of. And they said, look, if we combine these devices with other sensors or wearable sensors, we can go completely new levels of safety, for example. So I foresee that's going to happen.
Cool. Well, so it sounds very exciting. Congratulations on everything so far. And
thanks.
Thank you very much.
Thank you.